Hi everyone, let us discuss about two nuclear reactions, nuclear fission and nuclear fusion. I know all of you are familiar with these two words, nuclear fission and nuclear fusion. As the name implies, nuclear fission is a fission process, that is splitting up of a bigger nucleus into smaller one. And nuclear fusion, the combining or joining of two nuclei to form a bigger nuclei. Let us first of all we are discussing about the nuclear fission reaction. Nuclear fission reaction is a radioactive decay process in which the nucleus of an atom splits into two or more smaller lighter nuclei. So nuclear fission, we are producing smaller nuclei, and this process is always accompanied by a large amount of energy. That is the advantage of this type of reaction. It can produce a large amount of energy, and we can use that amount of energy in a productive way, such as producing electricity, etc. So, the system for producing energy or electricity from controlled nuclear fission reaction is called nuclear reactors. That is one of the application of nuclear fission. Nuclear reactors. In thermal plants, we are producing electricity by thermal energy, that is by rotating the turbine. But in nuclear reactors, we are producing electricity by nuclear fission reaction in a controlled nuclear fission. Here I am depicting one of the nuclear reaction. Here uranium-235 is bombarded with a neutron. It can split into barium and krypton associated with the 3 neutrons and a tremendous amount of energy, that is 210 milli-electron volt of energy. How this amount of energy is produced during this nuclear fission reaction? Here, if we are looking into the mass of the nuclear reactants before the reaction, after the splitting process, the reactants nuclear mass is atomic mass is always greater than that of the product mass. That is, a mass, some amount of mass is converted into energy as per the Einstein mass energy relationship. E is equal to mc square. So that is how this amount of energy is produced during nuclear fission reaction. And if we are looking into this reaction, this process is accompanied by 3 more neutrons. So what happens is that the secondary neutrons produced here is again collide with the target material. Here the target material is uranium-235, and it can produce further nuclear fission reaction to produce barium and krypton, and this process continues in a it is a continuous process. That is, the secondary neutrons produced again bombarded with the uranium nucleus, and it can further produce barium and krypton. So after a long time, this process, there are so many neutrons, and the process continues in a uncontrollable manner. So it can result in an explosion, and a huge amount of energy is released during this process. That is what is happening in nuclear fission bomb. Do you heard about atom bombs? And the basic principle is that in atom bombs, the principle behind the atom bomb is nuclear fission, and here the nuclear fission occur in an uncontrollable manner, and amount of energy released is very much enormous. So secondary neutrons produced is again bombarded with this target material, and this process continues until the material consumes fully. So, this self-sustainable reaction is called a nuclear chain reaction. Self-sustainable reaction is called a nuclear chain reaction. If the amount of the material is very much lower, it cannot undergo chain reaction or it stops there, and the nuclear fission stops there. So, the minimum amount of energy required to undergo a nuclear chain reaction is called the critical mass of the system, critical mass of the starting material. If the uranium-235 is below this critical mass, it cannot undergo nuclear chain reaction. So, the minimum amount of material to sustain a nuclear chain reaction at a constant rate is called the critical mass. If the amount of the material is lower than the critical mass, then it is called a subcritical mass, and it is greater. If it is greater, then it is called a supercritical mass. In order to undergo a sustainable chain reaction, there should be supercritical mass amount of the substance there. Here, a neutron is bombarded with uranium. Uranium-236 is first produced, then it can be split into barium and a krypton nucleus and producing 3 neutrons and an enormous amount of energy. So, what is a fissile material and fissionable material? Fissile materials are capable of sustaining a nuclear fission reaction by absorbing low energy thermal neutrons. Here, the neutron is low energy thermal neutrons. If it is bombarded with this low uranium-235, it can split. But in the case of fissionable material, the amount of energy of the neutron should be very much higher, or it can have a very much greater kinetic energy. That is, fast moving neutrons are required, or high energy neutrons are required for nuclear fission reaction. Such materials are called a fissionable material. Example for fissile material are uranium-235, plutonium-239, plutonium-241, etc. are the example for fissile material. Whereas the example for fissionable material is uranium-238, plutonium-240, etc. are the examples for fissionable material. So, in nuclear reactors, we are using uranium-235 for producing energy. But the naturally occurring isotope of uranium is uranium-238. So, it can be converted into uranium-235 first, and it can be used for nuclear chain reaction. Such type of nuclear reactors are called a breeder reactor. That is, uranium-235 is produced from naturally occurring isotope of uranium-238. And what is atom bomb? Atom bomb, I already mentioned that in atom bomb, the basic principle is nuclear fission in an uncontrollable manner. That is, the nuclear fission chain reaction occur in an uncontrollable manner, and it can produce a tremendous amount of energy. There are two methods have been used for producing atom bomb: gun method and implosion method. And all of you heard about, I think all of you heard about the atom bomb dropped over Japan during the Second World War. The first atomic bomb named Little Boy was dropped on Hiroshima on 6th August 1945, and the second atom bomb named Fat Man was dropped in Nagasaki and on 9th August 1945 by US. During Second World War. That is one of the drawback of this nuclear reactors. It can be used for destructive purpose also. And it can be, nuclear bombs can be produced by two methods: gun time assembly method and implosion. implosion assembly method. Here in atomic bombs, fissile materials such as uranium-235 or plutonium-239 are used for nuclear fission. To avoid a chain reaction during handling, the fissile material in the weapon must be subcritical before detonation. The amount of the material should be subcritical. So, in a gun type assembly method, two pieces of subcritical uranium-235 are combined by a little chemical explosion, so that these two subcritical pieces are joined together to form a critical mass or supercritical mass of uranium-235, so that it can undergo nuclear chain reaction in an uncontrolled manner. As a result of this chemical explosion, it can produce a trigger action for this one piece of this material, and it can join with the other piece of uranium-235. This type of method is called gun type assembly method. In implosion assembly method, here the material is placed in the core, and a large number of highly explosive lenses are placed in there. After the explosion, it is the mass of the material is compressed very much, so its density is many times increased. As a result, it can undergo nuclear fission reaction. And this type of implosion technique is used in nuclear weapons, modern nuclear weapons. Here, isotope of isotope of plutonium-239 can be used in the core, and it can be compressed by chemical explosion. As a result of its density increases so many times, so that it can undergo nuclear fission reaction. After the compression, a free neutron can be hit on the fissile nucleus. It can be split into small atoms called fission fragments, and it can produce further neutrons, and this process continues, and self-sustainable process produce more neutrons with the speed required to produce a new fission, and this uncontrolled chain reaction thus produce enormous amount of heat energy and leading to explosion. That is happen in atom bomb. And that's all about nuclear fission reaction. And you have an assignment, that is, you have to write about nuclear reactors, the working principle of nuclear reactors. And another type of reaction is nuclear fusion reaction. Here, the two nuclei can combine together to form a bigger nuclei, and one of the example is the fusion of isotopes of hydrogen, and the energy of the sun can be produced by nuclear fusion reaction. Here, the example is depicting here, and you can refer to your text for writing the examples in your notebook. And also the hydrogen bomb is working on the principle of nuclear fusion reaction. Here also it is based on the fusion reactions of various isotopes of hydrogen, and you can refer your textbooks for this reaction and write in your notebook. And that's all for nuclear fission and nuclear fusion, and thank you.